Hi, my name is Alexandra from KitFox Games. In this tutorial written by DPH Kraken, we'll make a Dwarf Fortress mod using Lua. You'll learn how to add a script file, register your raws, and incorporate random generation for a custom material. Lua scripting can be used by mods to generate new raw definitions, forgotten beasts, curses, magical interactions, mythical materials. These are all examples of procedurally generated content that is now run from moddable scripts. We recommend having some familiarity with Lua and raw modding for this tutorial. To start adding scripts to your mod, you'll need a scripts folder and an init.lua file inside of it. Let's make our script and have it log hello world. Once we've started a new world or arena with the mod, we can check the Lua log in our Dwarf Fortress folder to confirm that our mod is working. If your script won't run, then any errors will be documented here. Dwarf Fortress's generation script runs functions out of tables in specific contexts. The do once table is designed for modders to add new objects, and all functions in it are executed during world generation. Let's start by making a function in do once. We're going to define lines as a table and start the definition of an inorganic material. Let's call it cobalt. We'll add the generated info. It'll be a metal. It'll be a fanciful shade of bright blue, and it'll be a special material. We'll want to register the lines to the game with raws.register inorganics. This function takes a table of raws and reads it like it was a raw file. Let's also tell the function to print out the table to the log. In our arena, we can scroll down past adamantine and see our custom metal. In our Lua log, we can see that we've created a pretty standard material definition. You can copy this into your inorganic file in your objects folder and it'll load just fine. If we want to write a bunch of raws, we can take advantage of Lua to automate our workflow. Let's add a table of color tokens, then iterate over it in pairs. The IDs have to be different, so we'll use V, the value of the color being added. The metal will be named after its color, just in lowercase and of course colored that way. Now we also want some way to obtain it. We'll add a new table to store the lines for a reaction. For simplicity's sake, adventurers can just create bars out of thin air. We use the same name and ID variables to link it up to a reaction, which we can then register with the raws.register reactions function. In our arena, we have our materials for each color. We can spawn an adventurer and summon our chromatic metals. There are plenty of ways to add more data to each variant, but one of the main features of Lua for Dwarf Fortress is random generation based on world seed. Instead of doing every value on the table, we'll generate 1 to 10 variants in this loop using the C++ random number generator. We'll have our IDs be cobalt metal and I, the current loop count or iterator. We can use the utterance function to determine the name. This, of course, is the cobalt word generator. We can add another bit of randomness and roll on the table of color tokens to pick the color. Using pick, random, no replace removes the chosen value so there's no repeats. Let's fire up the arena and see our results. We'll make some Kimbasite bars, since they're the easiest to say. One of the main randomizer functions that Dwarf Fortress uses is generate from list. It takes a table of functions, randomly decides which one to use, and its output can be used to register raws. Vanilla procedural objects are generated this way for specific contexts. For example, each cave layer has its own forgotten beast, and each world has up to 20 divine materials associated with unique spheres. Mods can use the same tables to generate variants of them alongside or instead of the defaults. This is the default member of materials.divine.metal. If you've looked at the extracted raws on the wiki, then all the tokens here should be quite familiar. It returns the table M with 2 keys, raws and weight. Raws is a table of lines, like what we've been working with before, and the generation script automatically registers it. Higher weight value makes it more likely to be chosen. Also note the table metal by sphere, which the default divine metal uses to give each sphere the right properties. We can add our own entries to the metal by sphere table in our mod, such as for laughing metal. Let's say we wanted the angels to also wield our silly cobalt metals. In our script, we'll make our function be materials.divine.metal.cobalt. We'll take out the ID token and register function. since generators.lua handles those. Let's also take out the reaction generation and added some other properties from standard divine metal. Though this is formatted differently, it works the same. We'll have it return the lines, and it'll be on paper as common as regular divine metal. Default divine metal only has a valid result if there's a corresponding metal by sphere entry, but cobalt metal is valid regardless of spheres. In practice, it should be a little bit more common. If we don't want to compete for space with the default metals, we can overwrite that function with a nil value to have it not generate. Since we've defined divine cobalt metal, we'd only have that. If there's nothing that can possibly generate, then you could have a world that never generates divine metals, for example. Now that you've learned different ways to use Lua to add objects to your Dwarf Fortress mod, there's all sorts of things you could generate. You could make a new class of random monster, whet your appetite with a sorceress secret, or even use require to load script files for both of them. Stay tuned for the next video where we'll explore creature generation in depth. If you wanted to follow along with this tutorial as text, check out the Dwarf Fortress wiki. You can share and discuss all things DF modding in the KitFox Discord. The links for everything will be in the description.